Be statistic. So this is our call is this is our first video. So our goal is statistic for everybody everywhere. So today we are going to start the channel first video, that is introduction to statistic, and also maybe later we will discuss every section in statistic, and also maybe I'll show up that all some mathematical calculation, and also maybe later we will discuss some application based on R programming or SAS programming, and also some statistical packages for SPSS and Minitab, and even though Excel too. So in this case, in this presentation, first we are going to discuss some introduction. So in this case, we will discuss some important definitions and type of statistics, and also we will discuss the definition, population, samples. So those are actually popular definitions. First you should be understand the definition, and then type of data. So mainly we can divide it two types of data, and also we can divide it the data maybe based on level of measurement. And then why sampling, why we use the sampling in statistics, and also we'll introduce the data collection method, and finally we will discuss sampling method. So in this section we will discuss six important sampling methods we have. There are several types of sampling method, but in this section just to discuss important sampling methods, and also maybe I'll provide some snapshot so you can easily understand through the pictures that types of sampling method. That's why this sampling is very important in statistical data analysis. All right, first definition, data. So what's the data? Data is just observations such as measurement, gender, survival response. Measurement means height or weight or student marks, and gender type of gender, maybe male or female, and survival responses, yes or no. So these are just data. So statistics. So statistics is the science of gaining knowledge or fact, often by using sample data, and often the decisions are made under uncertainty. So in statistical data analysis, most of the situation we will use our sample data for our all statistical calculation. Then maybe finally we will make a conclusion based on that sample, that your conclusion present for general population. So actually in this case, this statistical this mainly discipline of this statistics. So first how to collect the data, and then how to organize the data, and then how to analyze the data, and finally make a conclusion from the data. So this is the standard steps in statistics. So maybe this different situation we will use different analysis method. So we have several analysis method, and initially collect the data. So in this section yes we will discuss that how to collect the data, and also how to organize the data. So maybe following chapters, following sections, we'll discuss how to organize the data and how to analyze the data, and finally how to make a conclusion from the data. Next type of statistics. So mainly we can divide it two types of statistics. So first one, descriptive statistic, and second one, inferential statistics. So descriptive statistics mean refer to the method for organizing the data and summarizing the data. So just only organizing and summarizing. So in this case, that is we call that is descriptive statistics. And some of the textbooks use summary statistics. That is also maybe descriptive statistics. And second one, inferential statistics. So inferential statistics mean refer to the method of estimating and drawing conclusion. So estimation and drawing conclusion with the population based on the information contained in sample data. So that is we call this is inferential statistics. So maybe first two set of videos, maybe we'll discuss discrete statistics, and then maybe we'll discuss inferential statistics. So next, definition, and what is the population, what is the sample, and also we will discuss what's the parameters, what is the statistics. So these are actually these definitions are very important. This should be understand the definition, what is population, what is sample, so how to define that population parameter, how to define that sample statistics. So those are very important. First, population, the complete collection of all individuals to be studied, so that is we call population. The collection is complete in the sense that it includes all of the individuals to be studied. So for example, scores or people measurement and so on. A simple example maybe, suppose if you consider uh, average height of US people, so that is population. So usually this population is too large. So and also second, so census means collection method of data from every member of population. Suppose if you consider any data analysis case, if you consider every individual in that population, so that's what we should be called, that is census. So sample, so sample means sub collection of members selected from population. So this is that population, this is the sample. So actually the sample, yes, we randomly choose that sample from this population. So actually this sample is sub collection of the population. So that means this is subset of population. So and also usually we denote it as big N as population and simple N as sample. So this is standard notation, and also maybe later we will use that notation in our slides or in our presentation. So actually in this section, this population definition and sample definitions are very important. So this is the simple example. Suppose you are president of MNSU. MNSU is one of the university. So that population or MNSU students. So it is look like maybe the size maybe 15,000 or 20,000. Ensemble or MSS students checking the class in the College of Engineering and Technology. So this is just in this case, this is a sample, this is the population. So in this case, this is all MNS students taking class in CSCG. So this is subset of all MNS students. So in this study, this is the population, this is the sample. And also, so suppose you are head of the mathematics department. So this situation, this population, all MNS students taking particular class, Stat 154 course. And there's a sample in all MNS students taking Mr. Myron class. So this is one of the particular class. So the situation maybe population size should be 400 or 500, and sample should be 30 or 25. So this is also in the example. So I believe you can easily understand through this example what's the difference between population and sample. Okay, next, parameter, a numerical measurement describing some characteristic of the population. So in this case, that characteristic mean so mean or average or proportion or variance or standard deviation or range. So those are characteristic. So suppose if you consider population average or population mean or population standard deviation or population variance, so those are we called parameters. And also maybe later we will introduce that notation too. So and also usually population parameters are unknown but fixed. So we can estimate that population parameters from sample. So later we will discuss that how to estimate the population parameters. So that's why you have to present your final conclusion for general population. Okay, and statistic. So statistic means numerical measurement describing some characteristic of sample. So earlier previous slide, we discussed that parameter. So parameter means characteristic of population. So in this case, that characteristic of sample we call statistic. So characteristic mean, population mean or population standard deviation or population variance. So those are we call parameter. So similarly here, sample means sample standard deviation and sample variance or sample range. So those are we called statistic. Okay. Next type of data. So in this case, first, usually we have two different methods for divide the type of data. So first method, mainly we can divide the two types of data. It is qualitative data and quantitative data. So qualitative data means not numerical data, and attribute or categorical data. So that is we call this qualitative. And quantitative data, numerical data. So just your values, maybe your output or your samples, maybe some numerical values. Or quantitative data or numerical data, so that consists of numbers represent count or measurement. So that means maybe possible answers or possible outcomes in some numerical values. Example, the length of time it takes for a light bulb to burn out. So in this case, the possible answers may be 5,000 minutes or 6,000 minutes. So that is answer maybe some numerical values. And second example, a question is given in a math class. The number of characters and words on a student quiz. So that is maybe possible answer 0 or 1 or 2 or 3 or up to 5. And also the ages of the respondent. So that is also numerical. So there is quantitative data. So next you are going to discuss about qualitative data. Some of the tags will use qualitative data in attribute data or categorical data that consist of names or labels representing categories. So in this case, your data's values not numerical. So just different category or different. That means this qualitative, not quantitative. Example, the gradients, male or female, of professional athlete, and season of birth, spring, summer, or fall. So these are non-numerical. And also another good example, a person's social security number. Maybe someone think about that social security number is numerical. It is not true. This person's social security number is one of the unique identity for you. So that is just actually that is label for you. So that is actually qualitative, not quantitative. That's very important. Moreover, we can divide the quantitative data for the we describe two types of discrete time and continuous time. So that's quantitative data. So quantitative data means just numerical values. So result when the number of possible values is either finite number or countably finite number. So that is maybe the possible values should be integer. So that means 0, 1, 2, 3 up to infinity, countable infinity. So that is discrete type data. So your output values or your samples are discrete values, not any decimal point. So that type of data is we call discrete data. The number of eggs that can lays. So these possible answers may be 0, 1, 2, 3, 4. And also second example, the number of questions that participant ask during a research study. So these also maybe your answer maybe should be integer. So this type we call it discrete type. And second, continuous type data result from infinitely many possible values that correspond to some continuous scale that harbors a rich values without gaps, interruption or jumps. So actually in this case your possible values in a decimal point. So infinitely many tests possible answers. For example, the amount of milk that cow produce. So maybe that answer, maybe you can, if you identify the exact value, 2.3431523 or something. So that's current 20. So in this case, the value is not any integer. So it is some decimal point. So infinitely many possible answers. So this type we call continuous type data. So the length of time it takes for light bulb to burn up. So actually this time also maybe we can try maybe 5,000 minutes to 60 50 second and some millisecond or something. So that means there is possible answers, maybe finally many possible. So these are type just numerical data, and just we divided the numerical data or quantitative data, just we divided discrete type and continuous type. So first you have to, if you identify discrete or continuous, you have to make sure your data should be numerical or quantitative, not qualitative. Okay. And next, another type of data, so we can divide the type of data based on level of measurement. So another way to classify the data is to use levels of measurement. So we have important four level of measurement. So in this presentation also we'll discuss based on the four important level of measurement. So first, ordinal type, nominal type, and interval type, and finally ratio type. So we can divide the data based on that level of measurement. This about nominal level of measurement. So characteristic by data that consists of names, label. So actually the nominal data must be qualitative data, not quantitative. So in this case, the data cannot be arranged in an ordering scheme. So we cannot write any order low to high or high to low, just only categories. So this type of data, nominal data. So and also you don't forget this nominal type of data must be qualitative data, not quantitative. Okay. So for example, survival response. So yes, no, undecided. So we cannot write any order. And blood type, the number of births by day of the week, and also maybe brand of motorbike, brand of cars. So we cannot write any order. So this type data we call nominal type data. And second, ordinal ordinal level of measurement involve data that can be arranged in some order, but difference between data values either cannot be determined or meaningless. So actually this is also qualitative data, but in this case we can write any order, low to high or high to low. And at the same time, the difference between two sample or two data is meaningless. For example, horse grade. So grade A, B, C, D, F. So we can write any order, maybe increasing or decreasing order. And also same time, if you calculate the difference between two grades, that is meaningless. For example, B minus A, that is meaningless. And 5-point agreement, strongly disagree, disagree, no option, agree, strongly agree. So we can write that order in increasing that agreement level or decreasing that agreement level. And type of drug usage, so non-infrequent, moderate, or frequent. So in this case also we can write some order. So these types of data we call ordinal type. So earlier we discussed that first type, nominal type. So nominal type also qualitative data, but that's the division, we cannot write any ordering scheme. But in this case, ordinal type data, this is also qualitative data, but we can write any order in increasing or decreasing. And third data, so interval level of measurement. So this is also like the ordinate level with the additional property that difference between any two data values is meaningful. So however, there is no natural starting point, zero starting point, where the none of the quantity is present. So for example, years. So in this case, years 1000, 2000, 1776, and 1492. So we can calculate some difference between 2 years, 5 years difference, or 6 years difference, or 100 years difference. So that is meaningful. But earlier, if you calculate the grading, if you calculate the two different grading between A and B, so that is meaningless. But in this case, the difference also meaningful. And same time, in this case, suppose if you calculate any ratio value, that is meaningless. Suppose if you calculate some ratio between 2 years, that is meaningless. So maybe in practically, maybe you can easily identify, you can, that is data, maybe this interval type data. Suppose if you calculate two data between two data or two sample values is meaningful, so their situation you can call that is interval level of measurement. And temperature of the ocean at various, and also here important this no natural zero starting point. So that means that temperature may be 0 degrees Celsius, so that means that is one of the measurement, not that is none of the quantity in temperature, that is meaningless. And also these are just example. And last, finally, final level of measurement, ratio. The interval level with additional property that there is also natural zero starting point, where zero indicated none of the quantity is present. At the same time, the values at this difference and ratio also meaningful. So example, price of college textbooks. $0 means no cost, absolutely free. And $100 will cost twice as much as $50 books. So in this case, that difference and ratio also meaningful. So this ratio level measurement, and also I also given some additional examples so you can easily understand through the example. So this is nominal level of measurement. So we have some several types of examples, so maybe you can easily understand through this example. So ordinal level and interval level and finally ratio level. And also in this case I would like to notice some important examples. So nominal case, uh, nationalities, and nominal case nationality mean maybe different nationalities. And also ordinal case, ranking of tennis players. So maybe some of the students think about the ranking of tennis players is numerical data, that is wrong. So this is rank. So maybe that maybe it is possible maybe first, second, third, or maybe we can rank 1, 2, 3. So that is just labels. Okay, so and this is also ordinal. And also temperature is level of interval level of measurement, and these are just ratio level of measurement. So I believe maybe you can easily understand through this example how to identify the nominal data or ordinal data or interval data or ratio data. Okay, next, why sampling? So why we used sampling in statistics? So what's the major advantages of in sampling? So cost is lower, data collection is faster, accuracy and quality of the data is high. So actually this sample, maybe in population always is larger values, so large number of individuals. So that situation, suppose if you collect the data from that population, you have to spend a lot of money and also a lot of time. But in this case, suppose if you consider sample, there is maybe cost is very low, and also maybe you can collect the sample data from that sample within a day or within a week. And also the accuracy and quality also high, because in this case maybe sample size maybe usually in the similar size, maybe maximum 100 or 200 or something. And also I'd like to discuss that correlation and causality. So and also we will briefly discuss about later in regression section. We'll discuss that correlation definition and how to calculate that correlation between the two variables. So just in this case, in this chapter, just I'd like to introduce that correlation and causality. So concluding that one variable causes the another variable, when in fact that variables are linked. Some of the situation we have some relationship between the two variables. For example, suppose if you consider two variables, volume of ice cube and temperature. So temperature is one of the variable, volume of ice cube another variable. So that situation, suppose this temperature increase, that volume of ice cube is decreased. So that situation we have that negative relationship between the two variables. Is that right? So that's the division we call, that is correlation. We have that is the some relationship between the two variables. So that is we call correlation. So two variable means things linked, and also in the example is smoking and pulse rate. So this relationship called correlation. So cannot conclude that one causes the others. But maybe later we will briefly discuss about that correlation calculation and also how to effect that correlation in our data analysis. So next, data collection method. So there are several types of data collection methods. So in the study we will introduce that important two data collection method. First, basic collecting data statistical methods are driven by the data that we collect. So we typically obtain data from two distinct sources. There is observational study and experimental study. So experimental study is very popular in medical field, and also observational study is also used. That is depend on the situation of your analysis. Study is just observing and measuring specific characteristics without attempting to modify the subject being studied. The example is study of accident rate in urban areas. So in this case, first you have to collect the data. So you have to observe uh, some during time period. That means in this case you have to observe, mean you have to count how many accident occurs in given time period in that particular urban area. So then maybe you can move that to analysis. So first step, you have to collect the data. So in this case, in this study we call this observational study. And second, we are going to discuss about experimental study. Apply some treatment and then observe its effect on the subject. So subject in experiment are called experimental units. So for example, a clinic give drug to group of 10 patients and a placebo to another group of 10 patients to find out if the drug has an effect on the patient illness. So in this case, just we use one the 10 patient group is the experimental group and another group is the placebo group. So in this case, this study is called experimental study. So just apply some treatment. So maybe some of the situation the treatment should be same sample size. Maybe sometimes it is maybe different sample size. And also this is very popular in medical field. Sampling method. So why already we discussed why we use sampling in data analysis. So in this section we are going to discuss how to select the sampling method. So there are so many sampling methods is available nowadays, but in this section yes we will discuss important 6 sampling methods. So first we will introduce some definitions. So simple random sample. So simple random sample are n subject selected in such a way every possible sample of size n can same chance between insertion. But maybe some of the situation that probability may be the chance of selected one of the particular individual in population. So that probability may be different. In some situations that equal probability, equal chance. So this is simple random sample mean is already that random sample mean here just arbitrarily choose the sample from that population and also the equal chance. So member from population are selected in such a way that each individual member in the population has an equal chance of being selected. So this then probability sample may be some of the situation that sample some the individual members get some high chance of selected. So that means probability is not equal. So that situation may be false. That individual member gets some higher chance, higher probability. So that situation that probability is not equal. So we call this probability sample. So in this section we are going to discuss that 6 important sampling method. So first random sampling method, and second one systematic sampling method, and third one stratified random sampling method, and fourth one cluster sampling method, and next convenience sampling method, and finally multi-stage sampling method. So actually in this case maybe you can easily understand through the title. This random, just we are going to select the random result, and second systematic. So in this case just we are going to select the sample in a systematically order, and third one stratified. So in this case first we split our population for different structure, then we just randomly select the sample, and for the cluster, and also in this case we have to divide some cluster point in the population. Later, okay, we will discuss later briefly. And convenience and multi-stage, and also actually in this case I'll provide some pictures so you can easily understand through the pictures. So hopefully I believe maybe you can easily understand the pictures. Pictures is very helpful for understanding the sampling method. This random sampling is selection so that each individual member has an equal chance being selected. So randomly select the sample. So but nowadays we have I think most of the statistical packages, statistical software has this option. We can generate the random numbers. But initially, maybe I think 40 years back, we have some random generated random numbers. We have some standard method, but in this case, I will not introduce that method. That's why everybody uses statistical packages or statistical softwares. Even though maybe you can use Excel also, you can use that generated random numbers. So this random sample, systematic sample. So in this case, yes, we are going to select a sample in a systematically order. So for example, select some starting point and then select every kth element. For example, in this case, in the picture, we select every fifth person as sample in the population. So this type we call systematic sampling. So just in this case, we select the sample in systematic order. Next, stratified random sampling. So subdivide the population into at least two different subgroups that share the same characteristic, then draw sample from each subgroup. So at least two subgroup. So in this case, that is we call spectrum. So maybe that's 3 or 4 or 5 or 6 or whatever. So at least true or more than true. Then after, just select that sample from each structure. So for example, in this case, just we divided the population as women group and men group. Then we select that sample from each structure. So this type we call that is stratified random sampling. Cluster samplings, so divide the population area into section or cluster, randomly select some of those clusters. So all numbers from clusters. So in this case, first we is split that just population with some cluster point. Then after consider all individuals some particular cluster. So randomly selected clusters. For example, in this case, yes, we consider 32 states in US. So just those are just average states in this case cluster points. Then just randomly pick that three clusters 5, 16, and 28 and interview all vertex. So this type sampling is cluster sampling. Convenience sampling. So convenience means just in this case just particularly choose some particular groups. So for example, there is annual stockholders meeting survey is conducted for all who attend. So this type is convenience sampling. So just convenience of particular groups. If the interviewer was to conduct a survey at a shopping center early in the morning on even day, the people that he or she would interview would be limited to those given there at that given time, which would not represent the views of all members of society in such area. So in this case, you actually just we select the same particular group. So I mean maybe you can easily understand through that picture. So in this case, just we are going to select first two those people as our sample. Okay, so this is just we call this convenience sampling. So stage sampling. So multi-stage sampling means just collect the data by using some combination of basic sampling method. So that means we used some random sampling and stratified sampling and cluster sampling. So that's division we call this multi-stage sampling. So in multi-stage sample design, pods are selected to sample in different stages, and each stage might use different method of sampling. So in this case, this situation we call multi-stage sampling. You can easily understand through that this video. Hopefully everybody understand this first section of our presentation, and also maybe continuously I'm going to explain every statistic section. So this just starting. So please don't forget to subscribe my channel, and thank you for watching. Thanks for everybody, and see you on next video. And also again, don't forget to subscribe my channel. Thank you. See you.